All right, in the previous investigation, we did a dilation in the coordinate plane. We specifically used the origin as the center of dilation. We dilated by a scale factor of 3. We saw a couple of things happen. We saw that all of the corresponding points were 3 times as far away from the origin. We saw also that all the side lengths were 3 times as big. And we saw that it looked like all of the coordinates, the xy coordinates, were 3 times bigger than the original coordinates. All right, so we're going to investigate in Geogebra. I'm going to also show you some advanced techniques here. The same exact thing, but we're going to do, we're going to take it off the origin, see if that affects anything, the center dilation, and then be able to look at multiple examples, okay, instead of just a single one with 3. So if you have access to Geogebra either on the web or on an app that you're using on some portable device, pull that thing open. And what we want to do is have a graph grid going on here. In order to get a graph grid, I'm going to tap on or select this, the gear settings. And you can see a menu will pop up and it says show axis. And I'm going to tap that to turn on the axes. And if you would like to, you can also tap the grid to turn it on. I usually don't like all of that stuff complicating my picture, so under grid type, I'm going to choose the major ones. Point capturing is kind of cool. So on automatic, as you get closer and closer to the intersection of 2 grid marks, it snaps it in there for you. You can have it so it fixes it to the grid or snaps to grid completely. I don't want to snap it to grid because it's going to really limit our possibilities, but the automatic is pretty nice, so I'm going to actually put that one on there. Let's see, what does label show me? Whole bunch of nothing. Okay, so I'm going to click on the white space. Now we have the same thing that we had before, but now we have a graph grid on top of our white space. Okay, now, before we get started in actually doing our dilation here, I'm going to show you a pro technique. So in the previous little investigation, in order to do our dilation, we were set with a scale factor that we typed into that box and we couldn't change it. So I have figured out how we can actually change our scale factor. And to do that, I'm going to go over here to the calculator tool. And under input, just tap that. And let's go over here to the alphabet, the ABC. And we can just choose any letter that we want to. Let's use K for scale factor because that's what letter we've been using all along. And hit enter and watch what it does. It turns K into a little slider that I can change, which is pretty cool, right? And now I can change some properties of this particular slider by clicking on the ellipse, the dot, 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 and I want to choose settings. And under the settings, you can see up at the top, it says it's the number K. Minimum value is right now at -5, which for us seems kind of silly. I'm going to change that to a 0. So I'm going to backspace out of that, change that to a 0, and hit return. Maximum's going up to 5. That seems fine. Increment is just how much bigger it's going to get each step. Under show, if I click that, it's going to put that slider up there on the screen for me, which is pretty nice. And the rest of this stuff is just fine. So I'm going to tap in the white space, and then I can move this thing forwards or backwards. And now this is a number that I can access within my sketch whenever I set that scale factor. So speaking all of that, I need to call up the geometry menu. And the way that we did it before is that we need a point. Now I'm going to suggest that whenever you start this out, just in the white space, tap a point. Don't tap it at the origin because then it's going to lock it in at the origin. You can't move it away. So just someplace in the white space here in one of these quadrants should be fine. And then let's make ourselves a polygon again. I'm going to make myself a triangle. It doesn't have to be a triangle. You can make a quadrilateral if you want to. Same kind of thing that we did before. And now I need to click more so I can see my dilation menu way down at the bottom. Choose dilate from a point. Tap your triangle. Tap your point A. And now when it says dilate from a point for our scale factor, I'm going to type in K. To get the K to type it in, under the menu bar up here at the top, I want to choose the ABC for the keyboard, type in K, and then click OK. And then bam, it has dilated it right now by a scale factor of 2.3. And then I can move this and change it now dynamically. That's pretty cool, right? All right, and like we did before, I'm going to collapse this menu so I can see kind of full screen. I can move stuff around if we wanted to. And let's change the color of this image to something different. Let's see, I haven't used orange. Let's use, I don't care for that color of orange. Maybe this one. Okay, that's a little bit better. All right, and then I can move stuff around, move this stuff around. And this is what I was saying, that whenever I get close to a grid mark, it should snap that thing in for me. Boop, boop. Same thing with these little points. It'll snap them in. Snap, snap, and let's do another snap there. Okay. All right. And then, like we did in the previous investigation, let's go ahead and draw in our light rays that connect from A to B, A to C, and A to D. So I'll call up that geometry menu, scroll down to the lines, and choose my rays. Tap A and then B, A and then C, A and then D, right? If I click the arrow button, the movement tool, I should be able to go back here and change these things to dashed if I wanted to. And I do. I totally do. Change those. Right there. Okay. And now move this stuff around. It looks great. All right. So far, so good. All right. And again, I can change this little scale factor right there. And you can see that when it's smaller than 1, when it's exactly 1, it hits exactly same size. Scale factor of 1 means same size, right? Anything bigger than 1, I can see that I'm enlarging. Anything that is smaller than 1, I'm shrinking it down, and it has to be closer to that center dilation. That's kind of cool. All right, now let's measure some coordinates. That'll be nice because that's what this whole thing is supposed to be about. So to measure some coordinates, the easiest way that I've discovered to do this is to tap on, let's say, B, and whenever the menu pops up on the screen, I'm going to tap the ellipse, and where it says Set Caption Style, right now it's defaulting to name. I'm going to tap that and choose Name and Value, and it'll put the coordinates up there for me. Okay, and I'll go ahead and do that for each one of these little points so I can see each one. Name and Value. Again, I tapped on one of the points, choose the ellipse in the name, choose that to name and value instead. So I'll do that to each one of these points so I can easily compare them. I think I got 2 more. One more. Name and value. I don't have to do that center. It's not that important. I want to be able to compare these. Okay, so right now let's move our scale factor something sensible, something that's going to be very easy to work with, like 2, so we can notice some differences between these or some relationships between these. And now let's look at the coordinates for point B right here. So right now I snapped my coordinates into -3, 2, and my scale factor is 2, so the investigation that we did before said that all we had to do is multiply our coordinates by 2, and I can get the new ones. -3 times 2 should be -6, but notice that that is definitely not where I'm at. +2 times 2 is supposed to be 4, but that's absolutely not where B prime is at. And the reason why is because point A is in the wrong place. Point A, in order for that little shortcut to work, point A needs to be, I'm going to collapse this menu, move this over, point A needs to be at the origin. So let's snap that into the origin. Let's move our shape around a little bit, get a better location for it. And now look at your coordinates. B for me is at 1, 4. My scale factor is 2. If I take each one of my points, my x and my y, multiply them by 2, 1 times 2 gives me 2, 4 times 2 gives me 8, and that's exactly where B prime is. Awesome, right? And if I look at D, D is still up on the screen. If I double each one of those coordinates, I end up at D prime, 10, -4 exactly. However, if I take that off, as soon as I take it off of the origin, it's no longer true. So in order for us to generate like some sort of coordinate mapping, it's got to be centered at the origin. And a lot of our coordinate mappings are just like that, that there is a very, very simple one, and then if I understand the simple one, I can do some transformations on the simple one to get something that's not centered at the origin, and we'll take a look at that probably within the next video, okay? Now, one other thing that I'd like to do, which I find to be kind of interesting, let me see if I can get all of this stuff on the screen here for us, all right, is like one of the things that we didn't do, like we started our K value, if I can pull up this menu here. Remember, our K value went from 0, which is nothing, all the way up to 5. Let's do something interesting here. Let's actually make it so that it could go from -5 to +5, and let's see what happens, okay? So I'm going to come up here to my settings, my ... on that slider, choose settings, and on the minimum, let's backspace out of that and then actually choose the -5 and hit return on that one. And now let's see what happens whenever I move this. Let's see what happens when it goes negative. Let's get rid of that. So right now it's at 1. That's nice. And what the heck just happened? What's going on over there whenever I made it negative? All right, so to help us understand what's going on here, I am going to suggest that we do something a little bit different. I'm going to come back here to the geometry menu. I'm going to hit the delete tool, and I'm going to get rid of all of these rays. That's it. And I'm going to turn those rays instead into lines. So click on the line tool up there at the top, and then click on A, and then click on B. So this time it's going to be a line. It's going to extend beyond our center of dilation, A and D, and then A and C. And if I click on this movement tool, the arrow, I can change the settings for that line. I do want them dashed again. I'm going to do that one more time too. Okay, and then one more. And change that dashed. Okay, now are you ready for this? All right, let's collapse this menu. Whoops, no, actually I want to keep this calculator menu up there. And notice that right beside this, the slider, it looks like a little play button. So I'm going to click that play button right there, and now collapse this. And now it's going to move. It's going to go all the way to 5, and then it's going to come back down. Comes back down. There's 1, 0, boop. All right, what happened? What did it do? Notice that the points stayed exactly on the same ray, just on the other side of A. And let me pause it. I got a little pause button here. Let me move it so it's like right there. So what do you think happened? My scale factor, we've talked about the scale factor is supposed to be this positive thing. It's a ratio of the side lengths. What happens if it's negative? Well, if it's negative, it still is doing a dilation. Let's see if I can make it -0.5, maybe. Right, whoops, right about there. Okay, so if it's -0.5, shape looks like it's about half as big, but I mean, it's oriented differently too. Look at where D ends up from D prime. Look at where C ends up, and look at where B is ending up. So not only does it get dilated, but it also gets rotated around when your scale factor is negative, and that's pretty interesting. Something to play around with for sure. Impress your family, impress your friends. All right, let's recap this then. Back in the slideshow. So what happens to any point under a dilation centered at the origin with scale factor of K? Well, that one's pretty easy. We just take our scale factor and multiply it times each one of the coordinates. So in coordinate notation, we're going to take the point x comma y, and it's going to get mapped to kx comma ky. Again, this only works with respect to the origin being the center of dilation. If it's not the origin, you got to do something else, and we'll see what that is in a future video. Before I move on past this, another thing that we were able to get from that investigation is, what can you tell me about the value of K? What has to be true about the value of K in order to make this thing, let's say, an enlargement, to make it bigger? What's got to be true about K? Well, K has to be bigger than 1. All right, then what has to be true about the value of K in order for it to be a reduction, to shrink your size down, the size of your pre-image? Well, it's got to be smaller than 1 and bigger than 0. So it's between 0, that's our compound inequality, between 0 and 1 is going to reduce it. If it was negative, then all of those things that we just talked about are true, but in addition to that, it's going to rotate the shape around into another quadrant, which is kind of interesting. All right, so in the next video, we will take a look at some examples that apply some of these dilation concepts.